It is just the most amazing experience to look up at the sky, be able to see that the atmosphere extends through your entire field of view. You're in this space, and all of a sudden it's like, oh my goodness, we're not just sitting in a vacuum of nothing. There is so much that's here, and we're in the middle of it. I am Dr. Carrie Black. I'm a program officer at the National Science Foundation in the Astronomical Sciences Division, and my job is to manage the National Solar Observatory. A solar eclipse is really cool. For us on Earth, it is when the moon passes between the sun and the Earth, and the moon casts a shadow on the Earth, and it blocks out the sun. In a total solar eclipse, it completely blocks out the surface of the sun, and so you can just see the atmosphere, which you can't see otherwise because it's not as bright as the surface of the sun. But eclipses happen all over the place. They happen on lots of different planets, not just on Earth. But Earth is very special that the moon is perfectly sized and situated so that it can completely block out the surface of our star. A total solar eclipse is, I think, the most popular type, and that's when the moon completely blocks out, or the shadow of the moon completely blocks out the surface of the sun. And that allows us to see the atmosphere, which is like diffuse and not as bright as the surface, but really, really cool to study. There are other types too. There's like a partial eclipse. A partial eclipse is when the shadow blocks out part of the surface of the sun. And then there are things like the annular eclipse that's happening on October 14th of 2023. And that is when the shadow of the moon blocks out almost the complete surface of the sun, but not quite. And so it leaves a very bright ring that you can still see. Total solar eclipses are great for studying the atmosphere of the sun, or the corona, as we call it. They allow us to see the corona that you wouldn't be able to see otherwise because it's so thin and not nearly as bright as the surface of the sun. But we live in the atmosphere of the sun. The planets all exist in the atmosphere of the sun. So being able to look at it and see what's happening there is unique to total solar eclipses. We study eclipses, and we use the idea of an eclipse, an artificial eclipse, to study the corona through our telescopes, both the ones on the ground and satellites. And that's where you put something up, call it an occulting disk. You put that up to block out the surface of the sun so you can see what's happening in the corona. But the thing that's really cool about natural eclipses is that the moon perfectly blocks out the surface of the sun, so you can see very close to the surface. You can see low in the corona, and you can't do that with artificial eclipses. The occulting disks are too big, basically. So natural eclipses are still the best way to study the atmosphere of the sun. So the sun and the atmosphere of the sun are plasma, so they're these collections of charged particles. And the atmosphere is in this very gaseous form, right? So there's all sorts of intense magnetic fields. It's one of the really, truly fascinating things about the sun is the complexity and intensity of the magnetic fields. And when you look at the corona, you can see structures like streamers or things called coronal loops, right, that kind of loop back down to the surface of the sun. Those are all magnetic features that have plasma flowing along it. And you can see things like coronal mass ejections, which are the big solar storms, right? The big, huge bubbles erupt off the surface of the sun. Yeah, it's really, the corona is really an interesting place. It's really cool. Okay, so this one's tricky. This one is tricky because you should not look at the surface of the sun ever without eye protection because the sun is so bright, right? It'll burn your eyes. It hurts if you try to look at it. However, in a total solar eclipse, exactly when the moon has completely covered the surface of the sun, that is the one and only time that it is safe to look up at the sun, and then you can see the corona and your eyes will not be damaged. The first thing is how amazingly dynamic it is. And so go look at movies of the sun. Go Google movies of the sun and look at them. They are so incredible. You can see sunspots up close. They twist into really complex features. They move across the surface of the sun. One of the things that really boggled my mind when I first learned about it was that the sun moves at different rates based on where you are. So like at the equator of the sun, it moves way faster than it does up at the poles. And it's because it's not a rigid body. It's not like rock, right? Because it's this plasma, it's like this fluid. It can move at different rates. So I thought that was really cool. And that all ties into things like the solar cycle, which every 11 years, the magnetic field flips. The orientation of the magnetic field flips. So if you start out with something that has a magnetic field that's basically like a bar magnet, then it gets twisted up over 11 years, and in part from this differential rotation, which is where the equator moves faster than the poles. Magnetic fields get really tied up and twisted, and then there's sort of a spring-like action that happens and causes the magnetic field to flip again. So I thought that was really cool. And that it happens on this time scale of 11 years. Like it's so fast, right? So we can experience it many times in our life. Another fact that I think is really neat about the sun is that atmosphere actually gets hotter as you move away from the surface of the sun. Right. So if you think about something like a fire or a heat source, when you move away from that heat source, it gets cooler, right? When you move away from the surface of the sun, it initially heats up, and then eventually it cools down. And this is called the coronal heating problem. And scientists still don't really understand why that happens. It's one of the ongoing areas of research. There's a lot of theories about it, but nobody has definitively determined why that would happen. It's an open mystery. I think it's pretty cool. Oh, good question. So sunspots were some of the first features that were identified, I think, by Galileo way back. If you look at the sun with eye protection, you can see sometimes these dark spots, and those are sunspots. We also call them active regions because they're active magnetic regions. So they're areas of high magnetic field, very high magnetic field that are in kind of complex configurations. And one of the reasons that we like to study them, besides the fact that they're this really cool, obvious feature that we can see, is that when they get into very complex configurations, they can erupt into things like solar flares and the coronal mass ejections. It is just the most amazing experience to look up at the sky and be able to see the corona, be able to see that the atmosphere extends through your entire field of view. Everywhere you look in the sky, there is the corona. You're in this space, and all of a sudden it's like, oh my goodness, we're not just sitting in a vacuum of nothing. Like, there is so much that's here, and we're in the middle of it. I think that's what really drives people to go travel all across the globe and see eclipses as often as they can. People should get out and see the eclipse. Go do it. Don't hide from it. Go enjoy. Even if you're in a cloudy place, it's still worth being out when an eclipse happens. And if you need any information on safety, please reach out to the National Science Foundation. We have the information for you.